Hello everybody, welcome back to Penrose Philosophy. Today we'll be talking about the evolution chart of a star. First you start out with a nebula, a big cloud of gas and space. In this cloud, the hydrogen gas accumulates into a mass, which then accumulates gravity, pulling more in, until it makes power that pushes outward, pushing the surrounding nebula back. And the result can be a few different things. First one being a brown dwarf. A brown dwarf is a failed star. It's too small to sustain fusion for too long. Is a red dwarf. Now this is a star that is barely a star. It is so small that it barely even makes enough fusion, but it is still stable, so it ends up lasting the longest out of any of these stars. Next, a regular star, which the smallest is about the size of our sun. The biggest can be maybe a couple hundred times as big as our star. Next is a black hole star. These are rare. A black hole star means when it was forming, it accumulated so incredibly much gas that as it was being made, a black hole was formed in the middle, and a star still formed around it. These are so rare because they could only be created when the universe was really young. Now, let's look at different things these can turn into. A brown dwarf stops right here. Can't turn into anything. A red dwarf turns into a blue dwarf, which quickly burns up fuel, and then into a black dwarf. A black dwarf is a star that is cold and fuses very uncommonly. It lasts so long that when the universe is at its end, that is one of two things that will be left. I think that after a ridiculous amount of time, near infinite, it fuses into a ball of iron. Now let's take a look at a star. This can turn into multiple different things. First being a red giant. This is the path our star is going to take. When the star is done fusing hydrogen, it moves on to fusing helium, which then makes it 100 times its size, which means it'll engulf the planets surrounding it. Venus, Mercury, and potentially Earth. Then this will turn into a white dwarf, which is similar to a red dwarf, except it's a lot more stable. Red dwarf can have solar flares and sunspots, making it cool or heat up, but a white dwarf gives off a similar amount of light and heat, but it's a lot more stable. These will also turn into a black dwarf. Is a neutron star. Might have heard of these a lot before, but a neutron star is when the star does a supernova and has such a great impact on the middle that it compresses it almost to a black hole. It's so incredibly dense that just a mere teaspoon of it weighs as much as a car. Something else a star can turn into is a black hole. Now this happens with the biggest stars, and it's a similar process to a neutron star forming, except it's a bit bigger, or a lot bigger, and it has such force onto the middle that it compresses to a singular point, zero-dimensional. I mentioned what the zero dimension is in my first video, and that is a lot of mass in a singular point, so it has a lot of gravity, such strong gravity that it pulls in all surrounding light, which makes a kind of a veil around it. That's why a black hole is black. Over a long time, it loses mass slowly due to Hawking radiation. A big black hole loses it slowly. A small black hole loses it fast. And then a lesser known option is a gravistar. This is a very confusing choice, but basically what happens is it's similar to when a black hole is forming, except when the supernova happens, it pushes inward so much that the inside gets pulverized and gets turned into pure primal energy pushing outward. So, two such incredible forces pushing on each other that it creates a shell. So, a gravistar is basically like a bubble that has such density, stretching it just a small amount would take the power of a supernova. On the inside is a perfect vacuum, and all that's inside of it is pure energy. And then for the last one, a black hole star. These are how supermassive black holes exist this close to the Big Bang. The way scientists predict, it shouldn't be possible for black holes as big as a supermassive black hole to exist this close to the Big Bang. So, they decided it's because of black hole stars. The black hole inside of the star has a lot to make it grow. An entire massive star surrounding it, feeding it at all times. So eventually it's gonna take in a lot of that, making it supermassive. Hope you enjoyed this video. If you want to see more like this, like, subscribe, whatever you want, share with others if you think you know someone who will enjoy it. And I'll see you in the next one.